大家好，欢迎收看这个星舰第10次试射的中文解说直播。现在讯号已经进来，距离发射还有44分52秒。我们来听现场的一些相关解说。
Flight test. We're not going to go all the way back to the beginning, but we're going to start with Starship's 9th flight test, which lifted off in May. That one did end with what we call a rapid unscheduled disassembly, or a RUD, on both the ship and booster. Let's take a quick trip back.
So Flight 9 marked the first reflight of a super heavy booster. We saw successful hot staging and the first ever deterministic flip, which gives us extra performance.
现在在进行这个前几次发射的回顾，特别提到第9次试射有一个重大里程碑，就是重新使用已经使用过的超载重助推段。但是很可惜在返回这个美国湾，也就是海面的时候出现问题。那今天是第10次试射，稍待我们有机会会介绍今天的一些测试目标。简单来说，今天不会利用这个塔降，就是不会利用发射塔来回收助推段。另外这一次呢，还是安排了这个释放模拟卫星，这是很重要的一个科目。事实上第7、第8、第9都希望能够做到，但是都没有能够成功。我们继续来看现场的一些画面。
To another one today. The booster RUD, we went back and looked at it. That was caused we had a much higher than predicted forces on the booster structure, really honing in on that internal fuel transfer tube inside. That was all due to that angle of attack experiment we were running for today's flight, and any of the remaining ones on this version of the booster. We're just lowering the angle of attack for the booster as it comes in, relaxes those forces, minimizes the likelihood that we see that kind of structural failure.
Yeah, and then over on the ship side, we redesigned the part of the fuel pressurization system that failed on Flight 9. We put it through a more rigorous test campaign and subjected it to flight-like stresses. And eventually, we were able to actually run it for more than 10 times the expected service life with no damage, which was super exciting. Yeah. Our goal is always, of course, to make it through all of the objectives we set. But any result that teaches us more about Starship performing in the real-world environment helps us to make those targeted iterations and improve quickly.
Yeah, that's kind of been the secret to our success. That's how we developed Falcon 1, our first rocket. That's how we developed Falcon 9, which we've already flown more than 100 times just this year. A little insane. And 500 flights overall.
Yeah, super exciting for Falcon 9. And again, we're trying to follow their lead and launch, learn, and repeat.
Yeah. So we finished Flight 9, we were getting ready for Flight 10, and if you followed along, we originally had a different ship number 36, that was slated to fly on Flight 10, but that experienced a pretty major anomaly during its static fire.
现在目前正在装填推进剂，推进剂是由这个星舰上层段开始装填接着在第2阶段会进行这个所谓 booster， 也就是超载重助推段的燃料装填。目前推进剂正在装填中，以上层来估算的话，装填的时间大概要50分钟左右，所以会一直进行到大概发射前才会完成。今天还是有60分钟的发射窗口，并且在接下来2天同一个时间，有没有备用的发射时间，我们还要来观察历经这个3个月的等待，可以说是好不容易等到星舰37号原型舰跟 B16 超载重助推段来负责今天的第10次的试射。那我们知道之所以会进行这个37号原型舰，最主要是36号舰在测试中发生爆炸。我们来听现场的一些解说。
The static fires did give us the data we needed to progress to launch, and are a prime example of our engineer and technician teams working together to build creative solutions to keep us charging forward to bring Starship online.
Even while we did all of that, we're still in the process of rebuilding that Massey's test site. That's where we want to continue testing our ships in the future, and we're getting it ready for that next generation of Starship version 3.
Yeah, very excited. I'm looking forward to it.
Yeah.
Okay, back to the rocket on the pad currently. Starship is the first orbital launch vehicle engineered to be fully reusable. It's built for frequent flights and a significant amount of payload.
It is the largest rocket ever made, ever flown, largest flying.
我们从昨天就可以看到这个马斯克亲自到这个发射现场的转播台来现身并且加以解释。另外他们的转播阵容也做了调整，可以说是从第10次开始有一些新的转变，也希望今天能够有更好的结果。
Largest flying object ever made, but this isn't on the radar for everybody, and we know that. So we want to kind of take a beat, pull back, do a little bit of Starship 101. To do that, I've got some special guests crashing the webcast today. Joining me now in Star Factory, Elon Musk, Chief.
哈哈，刚刚说这个说曹操到，昨天来现场，今天再来现场这个坐镇指挥啊。
Like high level, like why are we here? What the hell are we doing here?
Well, I don't know about everybody, but I'm here to try to build into the future that I imagined and dreamed of as a child, where starships with people are out among the stars exploring the universe.
Yeah, so the why, it's always important to explain the why of things. And the why of Starship is that we want to be a multi-planet species to extend consciousness beyond Earth, I think for two main reasons. One is to ensure the long-term.
对不起，这是昨天的录播的画面，就是马斯克上台来讲话。我再重复一下，这是昨天马斯克亲临现场的录影画面。
It's much longer. That's kind of the defensive aspect or life insurance for life collectively. But then there also need to be things that are inspiring and exciting, and that give you reason to live. Life cannot just be about solving one tragic problem after another. There must be also reasons to get up in the morning and be excited about the future. And a future where we are a spacefaring civilization is infinitely more exciting than one where we are not.
And we're doing it all pretty unique location. I mean, the pad's behind us. We got rocket on the tower. We got another tower with it. We're sitting inside Star Factory. And I mean, it wasn't like this for very long. This is all pretty brand new.
Yeah, I think we moved Starship here in about the early part of 2019. So we've been coming that entire time and seeing the site evolve from a double-wide trailer and a tent where we built Starhopper to the first suborbital test flights. And now
这在介绍这个星舰基地的一些转变大家可以稍微比较一下，就是右边是昨天的录影画面，左边是现场画面。可以看到天气的状况稍微有一点点改善希望今天天气状况不会是有任何的影响。
The most advanced rocket manufacturing facility that has ever existed. This is far beyond any rocket fabrication facility that has ever been built. This is essentially alien level technology, and it was all built here basically down by the Rio Grande River and close to the beach. It's an incredibly improbable location, and this used to be a sandbar. I think we're about 3 feet or about a meter above sea level. It really was nothing. If you see the time lapse from sandbar to two launch towers and a gigantic you can actually come and see the rocket. You quite close up. I mean, you can drive past it, and you can also look at the factory. And anyone could do this from anywhere in the world. So if you can come and visit and check it out. I think it's pretty cool that it's
just not right now.
Just not right now.
Just not right now.
Obviously not when we're launching because.
刚才我们看到的是星舰工厂的一些画面，我特别提到就是星舰工厂，我们刚刚有一闪而过，有这个大面积的栅栏格这个是为了调整这个姿态控制我们可以看到新的这个超载重助推段未来设计会把现在的4片改为3片，但是面积加大，这是暗示这个新的这个超载重助推段的生产已经进入到大规模生产的一个状态。不久后我们应该就可以看到 到新的超载重助推段能够推出使用。我们继续来听现场的一些解说。
Ultimately, thousands of ships to be built per year, which is what's needed in order to construct a city on Mars that is self-sustaining. And the major fork in the road of destiny will be when the Mars city is capable of surviving, even if the resupply ships from Earth stop coming
for any reason. And that reason could be something cataclysmic, or it could be that that civilization simply subsided. There's always this debate throughout history of will civilization end with a bang or a whimper. But either way, if the critical thing is to
get to the point where Mars is self-sustaining and can survive even if the resupply ships stop coming for any reason, which means that you need to build an entire base of industry on Mars in order for Mars to survive. For example, it's not simply enough to build a chip, like a computer chip factory, but you need the ability to build computer chip factories. So this is going to really take a lot of tonnage. I mean, my guess is at least 1 million tons to the surface of Mars, and maybe it takes less than that, but it's going to be a lot. But this is a very exciting future. It's one which will ensure the long-term survival and prosperity of life and consciousness, and it's the critical stepping stone to get from this solar system to other star systems, and perhaps go out there and explore, and perhaps we'll encounter.
您看到的是昨天马斯克亲临这个发射台参与转播工作的一个录影的画面。左边是目前的现场画面，目前推进剂还在装填当中啊。马斯克昨天有特别提到，就是他们希望能够打造这个人类是这个跨星球物种的这样的一个想法。另外就是希望能够在火星上建立聚落，最重要这个聚落能够有一定的维持能力哦，即使这个所谓的班船就是星舰未来万一不能准时到达的时候，在火星上也能够自力更生一段时间哦。这是马斯克昨天来到现场的一些解说。我们继续来看相关的画面。
Rocket out on the pad right now. We tell people like come down see it. It's hard to get like a sense of scale of just how massive this thing is. And we were able to catch somebody working on it a little while ago. And like part of the reason you said we're sending millions of tons, that's kind of why this thing is so massive.
I think in this image, Dan, you can actually see the person working at the bottom of the ship. And as we zoom out, you see the full ship, that sort of two-tone silver and black, and then the booster below it, right? And it really sets the scale, which doesn't come across, I think, other than in person. And when I do tours, I like to say Starship is real, Starship is big, and Starship is really big. And I think you can see there, and with the factory shots you saw earlier, again, we've got Flight 10 on the pad, but we got many more behind it.
Yeah, so I posted a video yesterday of just a brief scan of part of the Starship factory, and you can get a sense of the scale of the factory.
我们可以看到左边是现在这个星舰跟助推段在进行这个推进剂装填的一个程序哦。那他们会进行大概是50分钟左右哦。那整个进行的过程当中呢，是在超低温，而且是在这个翼状的这个推进剂注入的一个程序，特别是像是前天注入到一半，昨天是已经注入完成，没有发送怎么办？事实上，在没有发送的时候，它这些会在停止灌注以后，会让它这个释放到大气层当中。我们来看今天在发射准备的程序，可以看到是由星舰先装填这个液态甲烷，然后液态氧，接着助推段再装填液态甲烷跟液态氧。另外19分钟是这个冷却这个猛禽引擎哦。那我们也发觉以时间来换算，目前是瞄准是在4点半当地时间，对不起。当地时间5点半进行这个对不起，当地时间6点半，因为时区的不同我在美西是4点半进行发射，也就是说还有半个小时的时间。 现在在介绍他们的测试，这个应该是梅西测试中心哦。这个测试中心有一点可惜，就是在36号原型舰，昨天有网友提到，在测试的过程当中哦，有一个这个复合材料包裹的一个压力容器啊发生泄漏然后引发这个爆炸，不但呢炸毁了36号原型舰，更可怕的是把这个梅西测试中心的主要一些测试都造成损毁。这也是为什么我们可以看到37号原型舰是移到这个1号塔来进行静态点火测试的原因哦。这不是创举，是没有选择，是来这边进行测试。那也是就是说，这也有一点风险了。万一在测试的过程当中再发生爆炸，那对于这个发射塔会造成一定的损毁。另外，也有好消息，就是这个事实上，在36号原型舰发生爆炸后，SpaceX 花了非常多的时间对每一个复合燃料包裹的容器进行不断的测试务求能够安全。我们来继续看看现场的一些解说跟画面。
But then could be back potentially in one orbit, but in most cases several orbits. So the ship would come back several hours later, but then be caught by the arms and placed on top of the booster. You could also have multiple ships ready so that a single booster could service 5 or more ships, so that you could be flying the booster in theory, every hour. This is kind of a profoundly fast speed, obviously, for
他们提到未来等于说是循环再利用说是希望一个超载重助推段希望能够支援5次的发射任务，而且希望能够在短短1小时整备以后能够再进行发射，这是一个非常巨大的工作另外我们昨天也提到说新建工厂希望光是一年能够生产1000台的新舰，也就是一天要生产将近2到3台这是一个非常惊人的一个速度能不能做到，我们未来继续观察。不过这是原始的构想。另外，虽然画面上可以看到右边在进行这个发射塔的回收将这个所谓的超载重助推段进行回收，但是今天不会进行回收。好的，我们来看他们的一些详细的解释。
That would delay the reusability dramatically and would add a lot of mass with the landing legs. So that's why we catch the rocket with the tower arms, because it's the same tower arms that put the rocket in the launch mount are used to catch the rocket. And that means that we can put the booster back in the launch mount in less than an hour after liftoff. In fact, the booster is going to come back very fast. Like, 5 or 6 minutes later, this booster is coming back one way or another, or not coming back. So then you really have propellant fill time, which can be brought down to about 30, 40 minutes. And that means it is theoretically possible to fly the booster again in less than an hour.
I think when I think about it, it's the jet drives up to the jetway, the people get off, new people get on, and it leaves. You don't want to land the jet on a different airfield and then tow it over to the jetway. So it's just operationally simpler and faster.
Yeah, we've had a lot of success with the booster, 3 for 3 on the catch attempts when we bring it back.
您看到的是昨天马斯克亲临发射转播台参与讨论的一个画面至于我个人认为今天第10次测试最大的期待还是跟前面第9次一样，是期望星舰能够飞到印度洋降落，其他都不重要先让第2代星舰能走完测试流程，毕竟前面3次的空中解体加上1次的地面静态点火爆炸都让各界对于星舰计划的信心可以说大受打击。就算中间我认为说出了一点小瑕疵，有一点没做到，也没什么大问题，至少先走完整个流程这是我今天对于测试的一些期盼。
Either strengthening the tile or changing the how big the gap is between tiles. Changing what's underneath the tile. There's a 100 different variables that we could tweak with the ship tiles, the heat shield tiles. But the only way to know exactly what we should be adjusting is to fly repeatedly and be able to examine the ship upon landing. And we have successfully brought the ship back through the atmosphere and achieved a soft landing multiple times. So we know that this is possible, but we have in the process shed many heat shield tiles. So we need to be able to do this without shedding heat shield tiles and do so repeatedly.
And I think what you're seeing now is the Starship, this is CG of it coming in and landing on the tower, much like the booster, but there's some additional challenges there where we need to make sure we don't scrape the tiles off.
马斯克刚刚在解释啊，他们有信心能够将这个星舰，也就是上层段，能够带回这个地面啊。刚刚您看到的那个画面是这个电脑的示意图哦，并不是真正曾经做到过。他们希望在未来能够马上进行星舰舰体的回收。我们刚提到就是说，星舰这一次会测试一些这个隔热瓦的部分，希望测试舰体脆弱的区域啊，所以他们移开了一部分的隔热瓦，希望来测试耐热性啊。另外还会测试各种不同金属瓦片的选项。还包括一种具有主动冷却功能的瓦片，希望为未来这个隔热系统找到一些最好的方法。我们昨天马斯克在现场说，他说方法有的是啊，只是要经过测试才能找到最好的方法。另外，在星舰的侧面啊，也安装了这个所谓的非结构性配件来测试这些配件的耐热性，也安装了一段所谓的瓦片线哦。瓦片线的边缘被打磨光滑且呈现锥形，希望解决过去星舰在飞行测试中重入时观察到的热点问题。另外在画面上您可以看到是模拟动画关于未来在轨道上进行这个推进机转移的一个画面。
Two-stage rocket look like a many multi-stage rocket, and we get all of that performance, and we can take that full cargo bay now wherever we want to go.
Yeah, so a crucial technology that we hope to demonstrate next year is this orbital refilling, much like aerial refueling. It's essential for being able to send significant payload to Mars. So you essentially send a ship to orbit with a few hundred tons of payload, sort of a filled payload bay, but once it gets to orbit, the tanks will be mostly empty, and then you send up additional tanker ships to refill the Mars ship's tanks so that it can thrust from Earth orbit to Mars and have enough propellant left for landing. So this is orbital refilling is also not something that's ever been demonstrated before, so that would be a brand new technology. We obviously have at SpaceX figured out how to dock repeatedly with the space station. So in a lot of ways, this is like docking, and in some ways, it's easier in that SpaceX is docking with its own craft, but no one has ever demonstrated propellant transfer in orbit, to the best of our knowledge, and so this would be propellant transfer at a very large scale, and but with full reusability and propellant transfer, those are the
您现在听到的是这个马斯克，也就是SpaceX 的总工程师啊，在讨论这个未来推进器转移的一些计划。这是一个相当不容易的一个任务啊，特别是过去没有人做到在轨道上进行推进器转移，而且他强调这是一个大量的转移哦。我们曾经有为您在另外的视频当中有推演过。如果一趟这个星舰上升以后，在轨道上加注这个推进剂以后，进入往月球的轨道切入的话，可能要进行10几次，甚至到20次的推进剂补充，才能够让这个星舰上去以后，能够一次补足迈向月球的一个推进剂的容量 这是我所了解的一些状况。另外，今天发射几个看点哦，一个当然是热分离，但这个热分离从第9次开始采用一种方法叫做定向热分离，也就是上层星舰点火以后，控制喷发推离的向量，让下层段推开时朝希望的方向飞开。另外，今天也会搭载有效载荷演练部署8组的模拟的星链卫星，这个大小是跟下一代 V3 的星链卫星相似，它会跟着这个星舰本身的轨道运行也会降落在这个印度洋。另外，这一次测试还会测试这个所谓的在空中重启真空引擎，还有重入的时候会测试这个一些瓦片的耐热性，这是目前在测试安排上的一些项目。还有一点就是今天这个 booster 回来的时候，它不会进行打降，它进行这个阳面的降落，但是在降落上它玩一点小花样，它会把其中的一具的这个发动机给关掉，中间3个发动机中故意关掉一个，然后利用这个外环的一个等于说中环的一个发动机把它紧急点燃看能不能支援在降落点火时候能够保持姿态能够进入，这等于是一个紧急应变状况的一个最好的操演。好的，我们继续来看现场画面，现在距离发射只剩18分30秒。
All right. Obviously, that was really cool. There's probably not anybody else cooler on the planet to talk Starship with. Still very ready to sign up for that point-to-point travel, too. Also, though, it's really hard to relay just how much power is being generated by these engines on this rocket. We try to compare it to something like a little bit closer to home for people. We've used an airplane a lot of times. That's just something a little more tangible to folks.
Yeah, if you were to stack Starship up against one of the biggest airplanes out there today, the 747, just one Raptor engine is double the thrust of all 4 airplane engines. Super crazy to think about. And the Super Heavy on the pad right now, which has 33 Raptor engines, is putting out as much power as about 64 747s.
Yeah, it's, again, just a tremendous amount of power. World's largest flying object. It's crazy. And again,
在提到现在超载重主推段，以前我们也提载过，等于是64架747的一个推力
Remember, there's a lot of people that just don't know that all of this is happening. So it's cool to remind them, cool for everybody else out there to help us spread that word. All right. So right now we are 17 minutes, 12 seconds and counting until the 10th Starship flight test. While we do have a moment, though, let's check in over with Tyler Lionquist over in Hawthorne for the latest on Starlink. How's it going, Tyler?
Thanks, Dan and Amanda.
现在转接到哈耸的一个现场。
SpaceX. Starlink is SpaceX's low Earth orbit, high-speed internet that's bringing connectivity both on Earth and in space. Now, for today's mission, Starship is outfitted with 4 Starlink terminals, allowing us to get live views of ship while in orbit and all the way down to splashdown in the Indian Ocean. Our Starlink satellites are built in Redmond, Washington, which is also where we monitor the health of the entire constellation. So let's take a quick look for more on Redmond.
What a lot of people might not realize when they think about the scale.
现在可以说是这个 SpaceX 的带货时间他们一方面也是跟大家介绍目前在华盛顿总部所负责的星链的工作。我们知道星链卫星这几年发展非常迅速，而且在部件上面等于可以看到这个猎鹰9号不断的发射，能够快速的将这个星链卫星几千颗的星链卫星能够布满整个地球的轨道上方我们也发现就是说是目前它在运载上是以猎鹰9号为主，不过马斯克曾经许诺未来一旦星舰开始可以运作的话，他把所谓的猎鹰系列整个废除掉都不觉得可惜，所以 今天重要的演练对于发送星链卫星能不能够成功布放啊，也是一个观察重点。不过这个前提是能够让这个上层段星舰能够继续飞行啊，比较重要。那前几次只在这个分离后没多久，等于8-9分钟上层段的星舰就已经失去踪迹哦，这会是一个比较糟糕的一个状况。好的，您现在画面是介绍这个星链卫星它在制造以及准备的一些状况哦。还在继续介绍，事实上这一次第10次发射可以说是这个遇到相当多的挑战。在我这边时间星期一，可能是亚洲时间是星期2的早上第一次准备要发射，遇到这个地面系统有管线泄漏，压力不正常经过修复以后第二天就是我这边星期2，亚洲星期3的时间出现这个天气状况不稳定让这个发射受到耽延。我们继续来看现场的一些解说。
V3 satellites Starship will be launching in the future. And as you can see here, once Starship reaches a nominal orbit, the payload door will slowly begin to open to prepare for deployment. The Starlink satellites will be dispatched relatively quickly, one at a time, like a Pez dispenser, as you can see on your screen. They'll be situated in one long stack, taking up as little space as possible, allowing for an efficient deployment sequence. Once a set of Starlinks are deployed, the next set advances and deploys until they are all drifting away from Starship to prepare for their on-orbit life. Each Starlink V3 launch on Starship is planned to add 60 terabits per second.
这个我们昨天也有介绍过，这个利用类似糖果发送器就是上世纪的时候在欧洲传到美国有一种像是口香糖或是糖果可以发送，上面有一个卡通人物一按就会弹出一片片的糖果像糖果发送器一样能够来分送这个卫星。今天有朋友说能够走完一个流程意义更大，的确这个 Carol 他好像也非常爱好飞行看他网站上也有很多这样的内容。我也是希望今天能够顺利能够降落到印度洋，这算是证明这个第2代星舰本身的舰体结构跟它的设计上是有那个使用的一个迹象我们刚刚提到这个整个一个发射的过程，我们来看一下先前为您准备的一些这个发射的一些重要的一些程序您现在在画面上看到的是待会在发射以后的几个重要时间节点热分离不用说，大概2分38到2分48秒那个地方会是进行非常快速分离以后助推段进行回推点火。另外在6分40秒的时候助推段会熄火准备要降落，这时候他们会操作中间关掉一个引擎。另外18分到25分的时候会释放模拟卫星接着在37分钟进行重新点火，然后就是接下来重入的一个程序我们继续来看现场的一些相关的一些解说跟画面。现在距离发射11分20秒。
That's the biggest news that we were looking for. Again, weather is the main watch item for today, but we are green right now. We're not tracking any issues with the vehicle or ground systems, so we are looking pretty good for launch. We did all of our normal pre-flight checkouts with all the different vehicle and pad systems. At this very moment, we're almost done, or we're pretty far into our prop load on ship and a little bit more to go on the booster.
Yep, looking closely, it looks like we're nearly closed out on ship, like Dan said.
左边的示意图可以看到上层星舰已经将近96、97不断的在装填当中。那下层的助推段无论是液态氧跟这个液态甲烷的部分是70几也在不断的增加当中。
Little over 10 minutes to go. range is green, weather is green, vehicles looking healthy. We're looking good to launch right at the top of our window at 6:30 p.m. Central Time.
Can't wait. All right, now let's quickly talk about Mars, since everything we do is part of our foundational mission to get to the red planet. Each Starship launch is to learn more and more about what's needed to make life multiplanetary and to improve SHIP to the point where it's taking millions of people to Mars.
Yeah, we've shared the plan previously in the last couple of months. We're looking to start sending the very first Starships to Mars next year. These missions, not with people. We're just looking minimally viable landers, so let's just prove that we can get there. And so we're just going to focus on learning as much as possible, but looking at all of those different phases, you know, prop load, prop transfer on orbit, sending stuff out to Mars, doing the transit, doing the entry, and just doing a landing.
And in our next window, around 2028 to 2029, we're going to attempt to land the initial infrastructure and start delivering more equipment as well, while evaluating available resources on the red planet. And we will also have Optimus on board for the ride, who is designed to do the initial heavy lifting.
Oh, looks like we're doing some flap checkouts. Continue to increase the payload per ship, build out more infrastructure out there on Mars's surface, start to mine some of those resources, set up some propellant generation plants, build up some fuel and some oxidizer to send Starships back from Mars. By the
experiments on the first Starship missions to deliver customer payloads to Mars. So these payloads will include a plant growth experiment, a weather monitoring station, and also a radiation sensor to gather scientific data during Starship's approximately 6-month interplanetary coast phase from Earth to Mars, and also on the Martian surface.
It's a really exciting mission, makes showing up for work really fun for us. We're going to need to launch a whole lot more, though. So while we're just under 8 minutes away from launch today, let's head back over to Tyler and Hawthorne, talk a little bit about how we're going to be increasing the number of Starship launches going forward. Tyler?
Thank you, Dan and Amanda. So to put it plainly, in order to launch more Starships, we need to build more launch pads. And that's exactly what we're doing at Space Launch Complex 37 at Cape Canaveral Space Force Station in Florida. Now, Pad 37 has a storied history, most recently with the Delta IV rocket and for the missions for the U.S. government. And prior to that, the pad supported critical development for the Apollo lunar program in the 1960s. And we are honored to have the opportunity to continue making spaceflight history at Pad 37 with Starship. But first, we need to optimize the pad. So earlier this year, we started dismantling some of the existing infrastructure to prep the site for Starship operations. This will include up to 76 launches a year, with up to 152 landings at that location for Super Heavy and for Starship. And to support this flight rate, we plan on building 2 launch pads. Each will have 1 tower that can support launch and landing, plus deflector systems, launch mounts, and water deluge systems. This will also include a propellant farm that will produce propellant on site and serve both launch pads. So there is a lot of work in progress, but Pad 37 is only one part of our plan for Starship operations in Florida. A few miles away from Pad 37 at
现在在勾勒未来佛罗里达发射场跟这个所谓的Starbase， 也就是德州的 Boca Chica 这个地方2个发射场的建设的一个愿景未来这2个地方都希望能够建立这个2座的发射塔新建工厂的部分是设立在德州，也就是在 Boca Chica 所谓 Starbase 这个城市佛罗里达州的发射场可以支援一些特别是一些载人的一些太空任务这是目前他们在这个新建建设上面的一些规划。
So look good for launch here in Texas, so getting pretty close here with just under 6 minutes left. You mentioned Gigabay. We're currently laying the foundation for Gigabay here at Starbase as well, and we expect it to be up and running sometime next year. So yeah, there's a whole bunch of Starships on the way, and we're going to need more hands on deck. So come help us build the gateway to Mars. Visit spacex.com/careers to see all of our openings.
Yeah, I've been here for a couple of years now. Nowhere more magical, more inspirational on the planet. If you're a space nerd, you can come.
他们也在招募人手啊，欢迎这个有志的同伴可以一起加入。现在距离发射只剩下5分05秒。
Okay, so we are looking like we're about 5 minutes away from launch and heading into terminal count. Range and weather are continuing to look good, and prop load continues on both stages of Starship. We'll close out here in just a minute or so.
Yeah, we're just about done. It looks like, let me grab my numbers real quick. We're not tracking any issues. We are just creeping up to 90% full on the LOX on the booster, a little over 93% on ship. Fuel on the booster, and then ship we're just about to close out, so only a couple of minutes to go there. Once we're done, you've got just shy of 11 million pounds of liquid propellant on board those two different stages. We'll see a couple of final things happen. Well, you can't really see it. It's all going to be happening in our ground systems as we'll do pushbacks, clear all of the propellant out of those lines that are flowing up through the tower and into the vehicles, and get ready for launch. We just did our final guidance, navigation, and control system checkouts. Our flight safety system is being armed right now, and we're doing our final wiggle checks shortly with the engines on the thrust vector control. It's how we're steering the rocket. If we need to hold, which we are not currently tracking a reason to hold, that would come at T-minus 40 seconds. You saw us do that yesterday. We can hang out there for about 8 minutes or so right now. That's the point. It's built into the countdown. If we need to wait for clouds that just won't go the heck away or any other issues, we can hang out at T-minus 40 for a bit. But at the moment, we're not planning to do that.
Now, once we pass that T-minus 40-second mark, a number of events are going to occur in rapid succession. The ground spin and ignition systems come up to flight pressure. Ship will switch over to internal power. And after that, the QD arm lockout is removed.
现在在讲解一些发射的程序，目前在倒计时19分钟开始就已经进行引擎冷却，待会在前10秒钟会进行这个所谓的烈焰偏转水柱的激活。不过在发射前40秒可能会有一个暂停的节点，来决定是不是要继续交由电脑进行这个发射程序。很多看我们多次这个中文解说直播，大概已经非常熟悉这样的一个程序。
You hit a hold or an abort at that point, so we can refill water tanks. At this point, we're not sure if we'd be able to attempt tomorrow because we have fully loaded the vehicle. We have to do a lot of fancy scheduling to get propellant in here as fast as possible. But again, we've got a pretty heroic and amazing team that works all of those logistics, got us into our attempt today after we did a unplanned wet dress yesterday during our attempt. So really exciting to see. But we're coming up on 2 minutes. We've got a green range. We are green for weather. Green has always been my favorite color, only more so now. And we are not tracking any issues.
系统舰体本身以及天气状况目前都是亮绿灯，也就是适合发射。
Holding at T-minus 40 seconds right now, but in case we do pass that and any issues come up, we can recycle the count. We're pretty lucky that we have this ability. Falcon doesn't have that built in, but being a developmental program, this affords us a lot more flexibility, so super useful to be able to have that. But again, not currently tracking any issues, so hopefully we'll be good to launch today.
All right, coming up on 90 seconds. We've got a pretty good crowd gathering with us right outside Star Factory here at Starbase. Looks like we're getting a quick TVC, that wiggle check.
This is my favorite view of the rocket.
Right under the launch mount. All right, so we've got crowds gathered out at Hawthorne, crowds gathered here at Starbase.
Super fun to see people.
左边是德州星际基地室，右边是南加州的哈松，都有大批这个 SpaceX 员工在 这个期待这一次的发射。
So again, our hold point comes up at T-40, not
40秒是一个
tracking
观察
any
节点
reason to stop there, so we should see us go right through that. All right, we are through T-40.
继续哦，这
We
个
are
倒
counting
计时
down.
时
We're
钟
going to
继
let our
续哦。
flight director, Maciek Batura, take us the rest of the
30秒
way. 30 seconds, the 10th liftoff of Starship.
T-minus 15. T-minus 10.
10秒。
9, 8, 7, 6, 5, 4, 3, 2, 1.
升空，爬升，爬升。
We have liftoff.
Vehicles pitching downrange.
目前左边的发动机看似都正常。
Booster chamber pressure nominal.
We're a little over 40 seconds into flight. 33 out of
Booster and
33
ship,
Raptor
avionics,
engines.
power and telemetry nominal.
Getting good call outs, healthy systems on the booster as it starts to pitch over the Gulf.
好的，现在在爬升的阶段。
All right, we're a little over 1 minute into flight, about to pass through Max Q.
好的，在1分02秒，过了这个节点以后是 Max Q， 接着2分36秒
through the period of maximum dynamic pressure, max
主引
stress
擎
on the
部分关
vehicle
闭。
as it continues to fly.
Our next major event is going to be hot staging, which is happening in just over 90 seconds from now. To get ready, the booster will shut down all but 3 of its Raptor engines. The clamps holding the 2 stages together will release,
有
and the
一个
Starship
中
second
间的
stage
发动
ignites
机
its
看似
engines.
熄火。
The ship then
如果大
separates
家
from
注
the
意的
super
话，
heavy booster
在
and
左
heads
下
to
角。
space. At the same time, the 3 engines still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on the path for splashdown in the Gulf. As we mentioned earlier, the hot stage will be jettisoned for this flight, and that should occur just after the boost back burn. So we're about to shut down the first stage and perform hot staging. So let's just watch and listen.
2分36秒，Miko 也就是部分引擎会关闭。2分38秒热分离。大家注意看左下角有一具的引擎哦，没有能够点燃。
All right, seeing the engine start to throttle down.
Miko.
好的 ，Miko 也就是关闭部分主引擎，只留中间3具引擎。目前看来2分38秒、48秒分离，重新点火那一具引擎还是没有点燃哦。
Stage separation confirmed. We've got 6 engines running on ship. Booster is doing its boost back burn, continuing now towards its splashdown site in the Gulf.
右边的6具引擎是正常的在运作，左边的话有一个中环的引擎是熄火的状态。
You heard them report ship chamber pressures nominal, so that chamber pressure, just that expected thrust level in those Raptor engines on the ship. 3 vacuum optimized, 3 sea level, all looking good.
刚才他们提到这个舱压，他们一直很关心，因为过去几次舱压出现变化，导致星舰在中途解体。
From the ship.
Boost back burn shutdown.
All right, so at this point, we finished our boost back burn, so that was shut down. So that's the the first of the 2 burns after a launch that the booster is going to do today. So now it's headed towards the Gulf. It's not going to be quite as an aggressive of a flight down. We relax that angle of attack a little bit, but we are then going to be looking for it to do its engine tests for the landing burn, and those are going to be a little unique this time.
Yeah, typically we start with all 13 inner engines lit for that landing burn and bring that down to just the center 3. But one of our test objectives for today is to simulate what an engine out situation would look like. So we're going to be intentionally turning off one of those center 3 and instead lighting one of the engines from the middle 10.
6分20秒的时候会进行降落点火。
Shut down during the initial ascent. Oh, looks like we have hot stage jettison. You can see it floating away there to the left of the booster.
有点奇怪啊，照表来说的话，热分离环是应该在3分40秒就应该抛离，可以说是比预定时间稍微慢了一些。这个部分是资料有歧义的问题，还是出现一些状况？我们事后来进行检讨。
Very start of the landing burn, so we'll see if we light up all 13. But we've even done a landing burn at the tower with an engine out, so very resilient. We'll see how it does on its way down to the Gulf, though. All right, so we got a couple of minutes. That landing burn start should be just about 40 seconds away. That's always rad. You can see the.
有朋友说这个第2集怪怪的，一直在喷氮气，也就是进行这个姿态调整的一个状态。
All right, about 20 seconds to landing burn.
我们刚刚说6分多，6分20秒左右。看点不点得起来？说是先点3句，然后关掉1句。
All right, here we go.
点起来了。然后关掉外环，留中间3句，然后固定关掉1句，以中环的1句，这是按照计划的。
3, including one of the middle ring.
好的，距离海面0.3公里，越来越接近。哇，这个画面不错。
Down to 2. Nice little hover.
不错。今天按照计划顺利的降落，美国湾。
And the booster has splashed down.
好的，我们来看星舰这一边。
Meanwhile, back in space. About 7 minutes into today's flight, ship continuing its ascent burn. This goes until just about 9 minutes into our flight. That ship engine cutoff is slated for 8 minutes and 57 seconds. We are going to see those 3 RVAC, the Raptor vacuum engines. Those are the bigger circles in that little indicator on the bottom right of your screen. Those will shut down first, and we continue burning for a couple seconds longer.
大家可以看到，待会外面3句是所谓真空引擎，真空引擎会通常比较大，因为它喷嘴要喷出粒子来帮助这个飞行哦。
Views are looking great once again. Thanks to Starlink for getting us these views. It's just incredible. And we just heard the sound from booster.
It's like we just got a late boom from the booster.
目前还在飞行当中。
Yeah, we have ship engine cutoff coming up here just shortly. And as we mentioned, today's flight test is not an orbital flight, but rather one that demonstrates Starship's orbital capability.
星舰引擎关闭的时间是8分57秒。
All right, entering the final phase of this burn. Under 30 seconds to go.
8分57秒啊，要关星舰的引擎。
All right, shut down the vacuum engines.
真空引擎关闭。 好的，所有引擎都顺利
We shut down those center
关闭
three.
继续进
Successful
入
ship
巡
engine
航
cutoff.
状态啊。巡航状态相对是比较安全一点的，因为利用惯性在飞
Seco,
行。
baby. There we go. That's what we want.
Nominal orbit insertion.
All right, we just heard the call out for nominal orbital insertion.
前面炸太多次了，让人家有点捏把冷汗。
All right, so ship is in space. There we go. We're seeing the flaps starting to move into a stowed position. That's why it
星
looks
舰
like
是
your
进
camera's
入
moving.
太空领域啊。
Yeah, exciting to see Starship safely in space and super pumped to see all the team's hard work in action here today. And of course, as guaranteed, it's been an exciting day so far. We successfully lifted off right on time at 6:30 p.m. Central Time. Thankfully, our weather was looking good today. Yeah, and booster, we had our soft splashdown in the Gulf, so ship continues on.
Yeah, ship able to complete its ascent burn all the way in. You can see some of the shadows start to creep as it's going to be eventually flying into an orbital nighttime. So we'll see some daylight start to go away. But ship is in orbit, completed its burn. And, I mean, that's just the beginning. Now we've got a whole bunch more to go.
现在在巡航阶段，目前应该是飞越大西洋了。
That right there, we just saved the FTS, the flight termination system. That's that automatic flight safety system we have on the vehicle. So that is now turned off while ship starts its coast period. We are coming up. Our next milestone is going to be the deployment of those Starlink simulators. We've got some payload inside of Starship that we're hoping
快
to
速插播
deploy
一下，在
into
画面上您
space
可以看
for the
到，
very
在
first
18
time.
分钟
That
到
deploy
25
is
分钟
supposed to
要
start
释
at
放
about
模
18
拟
minutes and
卫星，这
27
里是一个非
seconds
常重要的
into
环
the
节。
flight, so just about 7 minutes from now. That deploy will take place over a couple of minutes. It'll go about 1 satellite a minute, so we'll be spread out over that. It might get a little dark, but we've got a couple of views that we can show you to see that deploy in action. After that, we're also looking to do a relight of a single Raptor engine while we are in space. We've done this once before.
在接下来的程序18分钟开始啊，每1分钟会释放一个星链卫星哦，然后在这之后，在37分钟左右会进行所谓的空中重新点火，这是一个相当重要的一个工作。大家可以看到下面有4个示意的这个图形哦，右边是它飞行的轨迹跟路径，接下来是右边第2个是一个它的姿态哦，以及左边是它的高度跟速度哦。可以看到这个速度是保持在每小时26,428公里左右，高度是在167公里左右。
Full attitude control, so we weren't able to go in, heat shield first the way we're designed to. So we ended up losing contact with the ship before we could make it all the way through. So you still get data, but you're not really getting the data that we want to make sure we're kind of stress testing the vehicle. As Amanda just said, we removed a bunch of tiles, and we do this in some intentionally scary places on the vehicle because we're really looking, are there spots that were vulnerable to this before we ever start moving towards, putting ship into a full orbital mission to then do re-entries a little bit later on. So really, really critical.
他们刚刚在提啊，这个有时候我在想，这个 SpaceX 不愧成为狠人啊，也就是他们故意在一些比较关键的部分，把这个隔热瓦是故意的移除，来看这个不锈钢合金哦，它能够耐热的程度。您现在看到的是画面，是舱内的星链卫星的一些准备要释放的一个画面。我们刚刚说18分，所以还有大概5分钟左右。
Main payload data, as we always say. And in fact, it's Starlink that's currently providing these views you see as Starship cruises a couple hundred kilometers above our home planet and provides real-time telemetry through every phase of flight.
Yeah, we took a peek inside of the Starship payload bay there for a second. So there's 8 of them. They kind of look just big steel plates, essentially. They're roughly the same size as those V3 satellites. When we do get that view inside of the payload bay, the payload door will kind of be on your...
我们网友说怎么感觉好像是打横的，事实上第二个图形的姿态控制非常重要，方向还在其次，最重要它不能一直打转哦。像前几次我们发觉就是说是一直打转，最后就失联了。
Start to go. We vent the nose cone, so we essentially bring it down to vacuum before we open the door. That was one of the things we ran into on the last flight, as when we had that fuel diffuser fail, the pressure in the nose cone became basically too high for the actuator of the door to open. So that's why we weren't able to get the door open that time. We have not seen anything like that on this flight. Everything's looking good with our fuel tank and our fuel press system. So we are hopefully just a couple of minutes away from seeing that payload door open and getting to our first ever payload. It's not the first payload we've ever carried, but it's the first one we're going to try and shoot off into space. All right, so I think we're supposed to open the payload door in just about a minute and change. And you're seeing a little bit of residual gas, and we open the door once.
能不能历史上第一次释放模拟的星链卫星？今天是一个非常重要的关键。
Vacuum of space, it's the residual that's left over after we've already vented it down. So kind of a cool light show, and then we'll get ready to deploy those payloads out.
我已经够紧张了，网友跟我一样紧张。他说他一直在看这个氮气调整姿态，而且刚刚一样啊。
And as we mentioned, so we have crossed over now at this point into an orbital nighttime. So views from the outside will get pretty dark, but
等一下舱门打开应该是漆黑一片了，因为在这个时区当时
later in the day here in Texas to try and get daytime views when we splash down. So it's daytime over in the Indian Ocean, where we are currently headed.
Just a few seconds until we expect those payload doors to open.
All right, one more time.
开不起来。
Open the pod bay doors, Hal.
我记得是18分钟，怎么会这么早？哦，18分钟开始释放，可能要先把舱门打开。哦，没有看到任何动静啊。
So we are currently in payload deploy prep.
还在准备阶段，应该是18分钟开始释放。如果没看错的话，舱门是在右边这个半圆形的环，大家可以关注这个部分。有动吗？有朋友说有动。
All right, so the payload door is open.
哎，开了！有没有看到在右边这个地方有一个很细小的一个环状的东西
？18 minutes and 27 seconds, so should be only about 30 seconds. So
18分左右，
one step closer. Hal, listen this time. He cooperated. He opened the payload door for us. There's a view kind of behind the Pez. You're looking out into the vacuum of space.
不知道能不能成功哦。
About 15 seconds until payload deploy.
哎，讯号。
Ship has transitioned to payload deploy.
18分27秒，应该是现在呀。 怎么回事？ 看来没有进行啊。哎，有在移动哦。出不来，好像不是那么容易。哇！第一次释放这个星链卫星，哇，可以看到2个现场，哇
Pew pew. Been waiting way too long to do that. There we go.
There goes another one.
看到左边有这个齿轮在带动，它滑出去以后，上一片补上来以后，它继续带动。
Super exciting moment, as you can hear the energy in both Hawthorne
终
and
于有一
Starbase.
点点进
Everyone's
展。
super excited for finally getting to deploy some of those simulated satellites.
Pez system moving down. Next row. There we go. As we said, we're going to do about one every minute or so. And this is just kind of a dress rehearsal for when we're going to be deploying the V3 satellites. And these are just a massive, massive increase to Starlink's capability. Each one of them has it's 60 terabits per second of capacity that's going to get added to the network per launch. That's 20 times more than what we're adding with every single Falcon 9 launch today, which, step increase in capability. There goes another one.
还有大概4-5分钟的时间可以释放。
All right, so as we said, we've got 8 total that we're going to go through today. It's about a minute for each one, but looking good on payload deploy.
又来一片。我可以很清楚看到这个镜头，有星链卫星从这边被推送出去了，像分送糖果一样。最后面几片啊。
All right, so we're about halfway through. When we actually start launching the V3 Starlinks on Starship, we're going to be flying about 60 each time. So it'll be about an hour to get through a full stack. But again, it's just going to be a massive increase in the amount of.
未来计划是1分钟释放一排啊，也就是说，在1个小时未来飞行途中，1个小时要释放60组。
Is part of just the Starship flight test program.
Yeah, absolutely. Always getting us that data, and yeah, the amazing views we have on the vehicle today.
目前看起来，除了助推段的那一个引擎没有点燃之外，其他测试项目到目前为止都还算顺利。想办法 cross finger 啊。
How deep does it go? All right, another one firing out. Pez looking smooth today.
等一下一个观察节点，也就是这个舱门能不能关闭，上次关闭是有问题的。 讯号看起来有点不稳定，又推送一片。这个推送还蛮重要，因为它如果卡在中间，舱门不能关，那是蛮麻烦的事情。
Almost there.
Yeah, there you go. 1 remaining, so 7 of the 8 have been deployed. 1 more to go. And then we will have completed our first ever payload deploy operation. Just a reminder, we're on a suborbital trajectory. These satellites on that exact same suborbital trajectory, they're going to burn up entirely and are on that same trajectory towards the Indian Ocean. So the last one has been deployed. Starlink simulator payload complete. Heck yeah, everybody.
可以看到接近非洲大陆。
Loving the energy from Starbase and Hawthorne.
我们来看看，已经空掉了，它的门可以被关起来。
There, now it's empty, looking a little lonely, but
现在要关舱门
Successfully deployed all the
舱门上次关
simulated
不好。
satellites.
really cool to see them all
有在动
out
吗？
there. Again, people that have followed know Starlink's really critical for the Starship program, in addition to getting all those views back from the cameras on Starship, which this is an external view. As I said, it's dark outside right now. The lights are off, so it's going to be hard to make stuff out. But in a little while, the sun's going to start coming up as we get to re-entry, which is going to be really critical.
等一下有一点天光会看得比较清楚。
I mean, we use Starlink for Starship data cameras. Also use it on the cameras that we use to bring you views of these launches, and also hopefully of the re-entry and splashdown.
目前星舰在巡航途中高度是190公里，速度是26322公里每小时。
With Starship, we actually get pretty insane. If you're in the space industry, you know bandwidth to space is usually pretty minimal. We get about 120 megabits per second. That's split between our high-definition video and real-time telemetry. We get that every phase of flight, including re-entry. So it's not just giving us views of re-entry, but we're getting all of that engineering data in real time through phases that it used to be impossible to get that in real time. So it's just really incredible.
Yeah, Starlink definitely affords us all this capability. And reminder, it's the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people all around the world, many of whom had never had connectivity before. Today, Starlink serves more than 150 countries, territories, and other markets, with over 6 million active customers and counting.
介绍一下星链，顺便宣传一下，让有需要的朋友可以跟他们订购。
And also introduced Starlink Mini, as well as an upgraded version of the Starlink Standard Kit.
All right, now with payload deploy complete, Starship is now going to close its payload bay door and continue to coast towards Earth, around Earth, towards the Indian Ocean. Sorry, I'm really excited today. We are in space, people. Still a lot of major events to come, though. We are looking to relight one of those Raptor engines at about 37 minutes, 33 seconds into the flight, followed by atmospheric entry, hell of a light show, and splashdown. So we're going to go on a quick break, take a quick coast, sit back, enjoy the views. A little bit dark now, but they'll get better soon. A couple of space jams. We'll be back in just a few minutes for that Raptor relight and then re-entry. See you soon. be lighting just one of those Raptor sea levels in the middle there. This is not a deorbit burn. It's a demonstration of what we'll have to do for deorbit burns.
重头戏来咯，重新点火。
We've done this once before. This is something we're really going to have to do when we're doing orbital missions. So it's a pretty critical test. We are just a couple seconds
所以
away.
是37分48秒左右啊。
Sorry, we're about 20 seconds away, psych. So we got a little bit more time. So we are going to see one of those Raptor engines light back up. We are through the deorbit demo gate, so we should be
右
seeing
下
it
角的
momentarily.
引擎应该是外围的引擎哦，成功
Relay
引
demo
擎。
startup
哎，对不起，中间点火，已
and
经
shut
成功
down.
点关掉。我们可以看中间一句水平海面引擎点火，
All
然
right,
后关掉。
looks like we confirmed the relight of one of those center Raptor engines. Second time we've done that. Super exciting.
Nominal
Huge
orbit
congrats
insertion.
to the team on this milestone. Very exciting to
That was
see.
a cool light show. Yeah, I get to do a mini
说
version
是已
here,
经完
so
成
again,
点火，
that's
非
going to be
常快
really
速，跟上
critical
次一样。
for when we're doing deorbit burns. Like as you're going through, which if you don't have one of these, my God, they're so much fun. But like you're able to actually like light. Oh, man, Dan, turn it on. Light that engine. Not set my co-host on fire. And that's what we'll eventually do to, break out of orbit, come back down to Earth. So really cool to see one of those engines light back up again in space. That was our last in-space thing.
Very exciting. We're going to be heading back for re-entry at about T plus 45 minutes. So we're going to take another quick break, and we will see you soon.
有朋友刚刚加入我们，跟您报告一下，今天目前都还顺利。有一句这个发动机在升空时没有点燃，不过都还算顺利哦，也完成了精彩的模拟卫星释放，以及完成空中点火，顺利分离，这是目前所进行的一些状况。这是回放刚才重新点火的一个画面啊。我们现在来看下一个时间节点。可以看到，在47分钟要重返进入大气层。
All right, so we are back. We are about 45 minutes into the 10th flight test of Starship. And as you can see, the light show has started. Re-entry has begun. We are starting to re-enter the Earth's atmosphere. We're moving about 5 times the speed of sound, and we're about to start barreling through the Earth's atmosphere and head for a splashdown in the Indian Ocean. We don't plan to recover the spacecraft today, but if we do make it all the way down to the water, who knows? But the goal of this part of the flight is to learn as much as we can about the ship's heat shield. A fully reusable, rapidly reusable heat shield for a spacecraft has never been done before. It's one of kind of the hardest engineering challenges still out there for us. And so this is the time to really dig in and get that data.
Yeah, absolutely. And re-entry is a critical phase of flight, so we'll need information on how the ship's system ends up performing. And Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests. Starlink provides us with one more path to collect data to help us rapidly iterate on Starship's design. And if the ship manages to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound.
Yeah, throughout history, a lot of times this is when you go into just a complete data and insight blackout, where that plasma sheath builds up around the outside of the spacecraft that blocks all of your signals that are trying to fight through to talk to either satellites out in space or towers down on the ground. Starship's big size kind of gives us awake, but what really helps us punch through is the fact that we're using Starlink. We're operating at just a much higher frequency. That's not what we want to see. So we just saw some of the aft skirt just take a hit. So we've got some visible damage on the aft skirt. We're continue to re-enter though. And again, we are intentionally stressing the ship as we go through this. So it is not guaranteed to be a smooth ride down to the Indian Ocean. We've removed a bunch of tiles in kind of critical places across the vehicle. So seeing stuff like that is still valuable to us. We are trying to kind of push this vehicle to the limits to learn what its limits are as we design our next version of Starship. So 47 minutes, 45 seconds into the flight, excitement ticking up a little bit on re-entry already, but the light show is continuing. This re-entry is going to take about 20 minutes or so until our planned splashdown. We were trying to splash down about 1 hour and 6 minutes into the flight.
刚提到这个过程，可能有一些这个摩擦、冲撞和一些未能设想的状况，整个过程大概20分钟。传统上应该会有一个黑障区，也就是讯号不能被看到和收到。
Yeah, the ship itself, it's a little over 50 meters tall. We've got those 6 engines on board, the 3 vacuum, the 3 sea level, and they're down in that aft skirt region, which
右下角第二个这个姿态非常重要。刚才我们这个莫须问网友特别提到，有一个大弓角进来。另外左边这个高度跟速度，大家也可以一并观察。
Only reliant on those kind of reaction control system thrusters.
We're going to continue hearing some callouts as the ship makes its way back to Earth. So when we hear entry max heating and entry max Q, that will mean the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through those, we can say we're doing pretty well.
I will say I'm happy re-entry cleaned off this camera for us. It was a little dirty from the weather, so thank you, Plasma, for giving us this view as we start coming down. The hit we saw to the skirt, definitely interesting. I will note, when we started doing these missing tile tests, we were intentionally removing them only in the skirt, as that's, you know, that's not over your fuel tanks or anything else that's kind of structurally critical for keeping the entire vehicle together. That obviously exposes your engines, so that could do some things for our landing burn, but for now, we are obviously continuing with this re-entry. We are committed. Indian Ocean, here we come. 50 minutes since launch. We're going going to see
高度已经降低了一半，等于说只有这个74公里左右。
we're in dense enough atmosphere that the flaps have control. So about 74 kilometers in altitude. And you were starting to see some sunlight, so we intentionally time these launches right now so we have daylight. The sun should actually come up over the horizon on Starship in about 3 minutes. So as we get a little bit further into this reentry, that inky black below you is going to start to look like clouds and hopefully a bright blue ocean as we make our way down onto the other side of the planet. We've got these cameras. These cameras are really cool. We added these several flights ago, looking directly at the flaps as not just the heat shield, but these flaps, how they're able to control the vehicle, withstand that reentry, the seal locations. So kind of where
右上角右上方有出现类似溶蚀的现象啊。
We will do missing tiles on those where, again, we're trying to, we're kind of being mean to this Starship a little bit. We're really trying to put it through the paces and kind of poke on what some of its weak points are. I mean, we even have missing tiles over some of those fuel tank sections of the ship itself. And so we're really trying to see what are our limits. We're doing this over a completely empty area over the Earth. Look at our Raptors there. We are, assuming we make it all the way down to the ocean in one piece, we will attempt a flip and a landing burn. We do have at least one buoy, everybody's favorite camera person, out in the Indian Ocean right now, being powered by Starlink. So that's at our planned landing location. So if we're able to get any live views of the ship, that'll essentially tell you that we
今天到目前为止都还算顺利，所以这是最后的一个阶段，我们也希望一切都能够按这个计划进行哦。
All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones coming up.
Yep, in about 10 minutes, like Dan said, Starship will be transonic. This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85, so that's 480 to 575 miles per hour or 770 to 930 kilometers per hour.
And after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now.
我们刚前面说这个马斯克是个狠人啊，他干脆把一些重要的关键点的一些隔热瓦的部分故意把它拆掉，来看抗皱能力如何。今天虽然我们会看到很多溶蚀的现象，不过这都有是在计划当中。
Extreme ways, but a little extreme, as we're trying to really stress the structure of the ship itself, specifically those aft flaps, so the ones in the very bottom of the vehicle. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are pushing it beyond essentially what we think we'll have to fly at to do something like a return to launch site. So again, may not be a very smooth ride downhill, but we're doing that by design. We're really trying to find what are the edges that we can operate.
第二代的星舰其实前襟翼的位置有进行调整哦，跟这个上一代是不一样的，也就是说今天等于说第一次是重入进行考验跟测试。
Basically just belly flopping.
很怕这种没有声音的一个状态。应该是进入黑障区哦。 就是看一下抗重能力。另外，莫须问刚刚一直在强调，就是这个弓角的问题、姿态的问题哦。这个能不能保持一个姿态，对于重入成功与否是非常非常重要。
All right, so about 55.5 minutes in, you can see the sun is up. Again, we intentionally designed these flights to lift off in the evening here so we get these daylight views so we can get as good a video as possible on the ship, assuming we make it all the way down. We've got at least one buoy powered by Starlink that's out there in the landing zone in the Indian Ocean, hopefully giving us a view again. If you see any live views, not from the ship itself, that means we nailed our landing target.
Starship is past peak heating.
All right, we just heard the call out that we're past peak heating, so things are looking good so far.
Yeah, looking good.
距海平面61.3公里。
Is that forward flap moving to try and just maintain control, maintain attitude of the vehicle as we're coming down.
待会在1个小时03分哦，它的速度会降到这个音速左右。
Checking in on one of our flaps. We got one of these cameras on all 4 of the flaps, 2 in the front, 2 in the back, giving us really good close-up views.
再看一下流程表。
We obviously don't have a camera that can see the entire heat shield. These give us kind of the best that we can do. But looking at those flaps is really, those are just, super critical for controlling the ship. You have some ability to maneuver kind of cross range. So as you're coming in, you can see in that indicator at the very bottom right that we've pitched up quite a bit. So again, we are maximally stressing those aft flaps right now. Looks like we got a little bit of burn through the very bottom part of it. Everything's still looking good. Ship maintaining control.
大家不妨看一下右下角那个地图位置，已经非常接近所谓的降落点。 右上角溶蚀的状况和几个点哦，可以看到在画面左边这个溶蚀的现象还是蛮明显。不过有前几次经验，好像也没那么可怕。
Again, we are intentionally stressing the flaps so we can learn all we can.
All right, so now we're already well past peak heating.
注意姿态啊！
48, 49, counting down to 48 kilometers in altitude. Expecting that transonic to come, so transitioning between the speed of sound and subsonics lower than the speed of sound in just a little under 4 minutes from now. And right now we've got kind of a lot of forward momentum, a lot of forward velocity, and then eventually by the time we hit subsonic. All right, here we go. So this is what we've been talking about, where we are going to essentially try to fully deploy those aft flaps and really stress them out. So again,
this is meant to test the extremes for the vehicle.
刚才这个姿态要保持住。
All
这个弓脚拉起来啊
See those flaps swinging out? Again, we are
哇，已经烧了
putting
差不
shit
多
through the
样
ringer on
子，
this
右
flight
右
end.
边这一大块整个几乎烧掉。但是控制功能还在哦。
It's like we're still maintaining control.
"只剩最后几分钟了，1分03会降到音速
Flaps
左
earning
右
their paycheck
，1分
today,
04
getting
1个小时
through kind of that
03
back
1个小时
stressing.
04左右会降到亚音速。
Definitely things looking good so far. We're about 2 minutes out now from Starship becoming transonic.
One cool thing to note as we get some of those views showing kind of the whole length of the ship,
没错
one of the changes
朋友
we
讲
made
他
after
旁
Flight
边的
6
激
was
励啊，
to change the tile line a little
距
bit.
离
So
海
we
面
had kind of
已经可以看
scaled
到
back the number of tiles
37点多公
significantly.
里
As when we go to catch these ships, you don't want to. I think as Elon said, you don't
目
want to
标
shock
就在
the
前
ship
方
as you catch it and knock all those tiles
最
off. So
后
we
几
knew
分
we were
钟
going to have to kind of peel back that layer a little bit. And the first time we did it was on Flight 6, and we saw kind of wrinkling and dimples almost in the ship as we were creating these hot spots in the uneven parts of the heat shield. And so to kind of address that, we smoothed it out. That's why you've got kind of that nice smoothed out black line now on the ship. And just looking at it, we can see kind of a little bit of hot spots.
如果正常1个小时03分哦是跨越音速，1个小时04分30秒降为亚音速，1个小时06分机动翻转，然后接着降落点火，1个小时06分30秒溅落海面。
Successful. So, all right, we are less than a minute away from hitting transonic. Again, pretty soon our forward velocity is going to look like it's kind of falling off a cliff, and Starship will look like it's falling off a cliff as we essentially go into our belly flop. If you watched some of the high altitude tests or suborbital campaigns, we were able to.
我们之前有讲到说，因为星舰的舰体够大，所以它那个电浆包覆不会那么严重，加上它把这个星链的卫星的天线移到背面，所以一路上我们看经过所谓的黑障区，并没有把这个讯号给包覆掉啊，还能够跟外面这个传送跟联络，所以我们一路可以看到一些画面，这是一个相当不容易的一个状态。好的，我们继续来看降落，现在马上要进行达到音速，降为音速。
All right, so at this point, we've dropped below the speed of sound, so Starship itself is subsonic.
降为这个亚音速，然后
We are
降到
starting to
亚音
chill
速
the
以下。
engines for a landing burn
目
attempt.
前降的速度、高度，
Landing
姿
flip
态
supposed to start in a
1分
little over 2
06机
minutes.
动翻转。
Subsonic
Yeah,
Indian
it's a
Ocean, we're on our way.
Starship is subsonic.
There we go. Farewell, space.
最后的关键哦，降为亚音速，1分06机动翻转，看姿态。
Right, so coming up in just a little under 2 minutes, so we're going to do the flip and the burn. So we're only using those
好的，
three
1分
center
06机动
Raptor
翻转，
engines.
接
The
着
sea
是
levels, the
降落
ones
点
that
火，
can
这两个
kind
最
of
最
gimbal,
重
that
要
can
的
move
关键。
around and steer. Dipping the nose down a little bit. Got 2 of our engines chilled in, waiting on 1 more. So again, we'll attempt to use 3 burns for that initial flip. We eventually go down to just 2 Raptors for the end of the landing burn.
Just about 1 minute now from that landing flip and landing burn start.
1分06，机动翻转会整个立起来。
Structurally, we're looking good. Got good pressures in our nose cone for everything.
进来咯，距离海面只有2公里。
Again, we're going to look for the flip. So Starship's doing its belly flop right now. We're going to do the flip. Swing out. Let's punch through some clouds first.
$1.06。
Here we go.
Starship landing burn startup.
哎，调整过来了。不能过头，不能过头。回来。
There's our flip.
好，右边引擎。There's
a buoy.
但没看到点火。姿态是调整过来，但没看到降落点火。
Hey.
今天这个达到我希望目标，能够这个顺利的，可以走完全程哦，已经是非常不容易。
Splash out of the Indian Ocean. There we go. All right. That was pretty awesome.
Incredible flight
cool,
today
right?
for both ship and booster.
Yeah, really incredible. So obviously we're excited here. It looks like everybody's excited over there. Tyler, how's it going over in Hawthorne?
We are super excited here in Hawthorne. It was another exciting Starship flight test in the books, and we hope you enjoyed those Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed enormously to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that's going to wrap it up for us here in Hawthorne. Thank you to everyone for tuning in today. It was great being with you today. Back to you guys.
That was absolutely incredible. Huge congrats to all the teams here. Again, we lifted off from Starbase, Texas, right at the top of our window at 6:30 p.m. Central Time. We saw Booster successfully lift us up through ascent, had a successful hot staging where ship continued on with its suborbital trajectory. Booster came back down, had that boost back burn, and a successful landing burn with that unique engine configuration as well.
And then ship continued on its way, made it all the way into space. We got to see first ever payload deploy.
So exciting.
That was awesome. We got the door open, 8 Starlink simulators deployed, relit that Raptor engine, and then on entry we probably gave it a little bit of extra time in the oven, but made it all the way through re-entry. All 3 engines started up, landing flip, splashdown in the Indian Ocean. Promised maximum excitement. Starship delivered.
Most
so
definitely.
Congratulations.
谢谢我们网友那个 Carol 告诉我们，不是这个 Win 告诉我们说反推成功哦，他已经拉回去看了，反推成功哦。
And we'd also like to thank the fine people of Cameron County, including the residents of its newest city, Starbase, as well as the Coast Guard, the Federal Aviation Administration.
现在开始感谢各部门，感谢海岸防卫队，感谢太空总署，感谢各个单位的支持。
This is just a tiny amount of the views. We have so many views that we didn't get to feature on the broadcast. So we're going to be going through that over the next couple of days, and we'll be posting it all there.
Yeah, if you're interested in more launch coverage, head on over to spacex.com/launches for the most up-to-date information. In fact, we actually recently rolled out a new departure board featuring our upcoming launches with details like mission name, launch and landing site, and liftoff time. So be sure to check it out.
All right. We just launched the world's biggest rocket. Again, dropped a couple satellites off suborbital.
Incredible payload deploy for today.
Nailed that double header into the ocean, splashdown, time to go through the data. Really crazy cool to hit all those objectives today.
Yeah, huge shout out to all the teams who make
谢谢网友
this
分
look easy.
享，他说
And thanks to all of you for
最后
tuning in,
100
and
米
we
的
will
时
see
候
you back
点
here
火。
for Flight 11. Good night.